everyone, my name is Chandrika Srinivasan. I am the product manager for the Apollo router, and with me I have...
Hello everyone, I'm Benjamin Kunen, working in the router at Apollo GraphQL.
Right, and today we are here to talk to you about response caching in the router. So we're going to sell caching to you, but I'm guessing that since most of you have signed up for this talk, you already probably know what caching is about and what benefits it can bring to your business. But you're potentially here to learn more about what is response caching in the router, and should you even bother with this? Like, how is this different from any other kind of caching in the stack, and how could you benefit from this? But before we get into the benefits of caching in the Apollo router, let's sort of align on really the benefits of caching and why we do that, right? And for this, I want us to experience something together, a bit of frustration. So this is a beautiful site, but it just takes too long to load. And this is a common frustration, right? All of us can really empathize with this, can feel this, because we are so used to the immediate responses that we have with our applications and website. Our tolerance for delay is actually quite low. So as builders of platforms, as builders of applications, we do understand that every delay of every second means lost engagement, lost patience, and lost love for your product. And this is what caching can help you with. Now, before we dive into this deeper, let's think about what is actually causing this delay, or what does it even take to render a page like this? So I have a very simple view of what a stack might look like. So here I have taken the liberty of representing a federated GraphQL API, but really this could be any kind of API. It could be a REST API as well. And it's got some very similar layers in the stack. So there is the client, then there's some sort of load balancing, then there is your API gateway, and then it's backed by the services or the databases where the data is actually coming from. So what happens when a user clicks on a link or loads an application? The request is taking a scenic route down the entire stack, right, layer by layer, through the load balancer, through the gateway, and through each of the services till it gets to the database and then back up again. That's hundreds of milliseconds of delay per layer, and now multiply this with per user, per request, and that delay can be quite significant. So what if we could reduce this round trip time? And this is what we do traditionally with something like when we have traditional forms of caching, like the CDN here that we see. So if I had a CDN, which is a very common mode of caching close to the client, that would reduce my round trip here. CDNs are great when you have static websites or really simple pages. And what the client does is the first hop is to the CDN to see if the request can be satisfied from there. The other thing that I have added to our simplified layer here is caching at the Apollo router. What this does is we use Redis for caching. And this, again, you can see how it has halved probably the time it takes for the request to get to the subgraphs and back up again. Now, either one of these methods could help significantly to reduce latency, but both together could really transform the experience your users will have with your API. So not only does it make your responses faster, by avoiding the traffic to your upstream services, you're actually lowering your infrastructure costs. And a little later in the presentation, we'll talk about some real stats that we're seeing with our customers, how customers have actually been able to scale down their services because they are experiencing lower traffic to their services. And of course, more load less load means more resilience. And this is going to get even more important as we head towards this. We heard in the keynote today, it's all about agentic AI. It's all about agentic applications. And this is only going to increase the load on your API, your stack. So any optimization that you can make in your stack today is going to reap benefits tomorrow. And caching is one of those superpowers, right? It makes our systems faster, cheaper, and more resilient. And when you see that API volume surge, every little helps. Now, you could say, all right, but I already have CDN caching. What does this mean for me? Why should I really use caching in the router? So now with CDN caching, like I said, this is a very popular way of caching, and I'm not going to stand here and tell you shouldn't do this, right? Like, because it clearly has the benefits of that. Again, but then there is a typical use case for it. If your website is quite static, or you have a simple page, you can use the CDN where you can exactly sort of, if the user comes and asks for the same static website, you can sort of serve up that request from the CDN. But as we know, GraphQL requests can be dynamic. Each request, depending on the user, depending on the auth headers, can be quite different. The selection set can be quite different. And in that case, the CDN actually returns, the cache hit ratio really reduces for a CDN. You could also cache this at the services level. And again, this is beneficial because databases are the real bottleneck here, right? Like if you can avoid that read from database, that also reduces your latency. But as you can see, if you actually cache all the way down to the service level, you're not really saving from reducing that round trip down your stack. Plus, this also means additional cost of ownership for you because you're now maintaining your infra. Each service is probably reinventing the wheel by implementing their own caching. So this is a little bit of wasted effort here, and it really don't get the benefits that you could reap from caching. And really, Apollo Router is the sweet spot here because this is GraphQL aware. It does understand that there are different paths to a given response that is coming from a website, and it is able to cache separately the entities and reuse them across requests and users. And this becomes really powerful. And again, a combination of these is what we're looking at. Now, let's look at this practically, right? Like I said a lot about, CDN is really good for like simplified caching. Router understands more about like the GraphQL aspects of it. What does this really mean? So again, I have a simple stack here. As you can see, I'm using both the CDN and caching at the router level. So what happens is, and now I have a website here with the website that we saw earlier, which failed to load. So now I have a product page here, and it has quite a few elements in this product page. There is the product information, there is the price, there are some reviews here, and there is some stock availability. As you can see, one of the colors is not available in this for this bookshelf. So actually, this page is rendered by different components, different parts to the response. So now what happens is at the CDN level, this gets cached as the entirety of this page. So if a user comes back and clicks on this product, which loads the product description for this particular bookshelf, this is something that can be retrieved from the CDN, right? And so easy peasy, this works this way. But what the Apollo router does is, it does understand that there are different components to the response, and it actually splits that up. It saves it as, the product details, the price, the reviews, and the stock all separately. Now, this is a twofold benefit. Not only are these entities reusable elsewhere, or these cache entries reusable elsewhere. For example, let's say a user with cart, they're on their cart page, and all you need is the product information. Now with the CDN caching, you cannot reuse that because that is exactly for this page. So if somebody requests this page, you're able to get that from your CDN cache. But if I just wanted to reuse the product information in a cart, for example, I can leverage this cache entry here and retrieve this from the database, from the Redis database. Additionally, if you think about it, all these components have widely different TTLs. For example, reviews and the stock could change quite quickly, whereas the product information and price are relatively static and won't change that often. But when you cache the CDN, you have to go with the least TTL because you cannot afford to serve up stale data. And that's why you are going with the least amount of TTL there possible, and probably again resulting in very low cache hit ratio. But with the caching at the Apollo router level, you are able to invalidate these independently, have TTLs for them that are different so that they do expire at different points in time. All right, so we've been talking about how caching in the router can be really beneficial and can have a great impact on the performance of your stack. So what do we have today? So caching is already available in the Apollo router. This is in preview. This has been preview for a few months now. And what does it support? It supports your basic TTL-based expiration. So that means that you can set your subgraphs to cache responses. You can set specific TTLs on specific queries and entities, and those get cached. This is already powering actually production use cases, even though this is just in preview. There are some really great stats here that I want to share actually. So this is one of our most used router features today. There are more than 85 billion requests that we receive every week, and so the scale is quite massive here. Some of our customers, have talked about how they've really managed to scale down their pods because now they're seeing reduced traffic to their services, which means they can afford to have fewer pods running in production. And of course, the cache hit ratio increases. If you just had your CDN cache, as we saw, because your TTLs have to be really low, you probably expire or invalidate those requests pretty often. But then when you add router caching to it, your cache hit ratio really increases. And of course, like we said, reduced traffic to your subgraphs. And the bottom line that why all of this really matters is the user experience, the end user experience that you will get from enabling caching in the router. All right, so all this goodness is already available. So what is coming next? Well, why are we here? Why are we talking about this? So we do realize that anything that's got to do with optimizing the stack does take time. You require the tools, you require the right tools, the right metrics, the right visibility to understand. You have to know your supergraph. You have to understand which subgraphs could benefit from caching, which operations could benefit from caching. And sometimes it just feels really hard to get started, right? And also when sometimes these things are in production, it can be a bit of a black box and you might not have that visibility of how these features are actually working. And to that end, what we've done is we have put in a lot of effort to make caching effortless. So what we are introducing are new metrics and out-of-the-box APM dashboard templates that allow you to get started, allow you to monitor the performance of this feature. And we also have, this is actually one of my favorite things, the new cache debugger. And if you've used the connectors debugger, you will see how it's a very similar experience. And what the cache debugger helps you do is, whether you're getting started or whether this thing is already in production, it gives your developers the chance to really look under the hood to what's happening for a given operation. What are the entities that are getting cached? How long are they getting cached for? Where are they getting fetched from? And then we'll see more of this in the demo later. And another thing, we are introducing a new directive. Like I said, in the preview today, we do support TTL-based caching. But with this new directive, what we now support is programmatic granular invalidation through cache tags. But we'll see more of that in the demo. And with that, I'll invite Benjamin on stage. Over to you, Benjamin.
Thank you. Hello again. I'm going to show you a quick demo of response caching now. For the purpose of this demo, I'm gonna use a small project. It's a blog post project with here, for example. We have the top blog post here, the top post. If we click here to see the details, we can see the title of the blog post, the content, the author here, the email of the author, and so on. So I'm going to show you a little bit about the subgraph. We have two subgraphs, a post subgraph, which contains different queries to list the top post, for example, and the post entity, and we also have a user entity coming from the user's subgraph here, and a user can have an address, email, and so on. So here I'm gonna I will switch between two different personas to introduce you how it would work in the real world. I'll switch between a platform operator and a developer on a subgraph. So I'm going to use my cap to represent it physically. So without my cap, I'll be a platform operator, and with my cap, I'll be the developer. So now I am a platform operator, looking at my Grafana dashboard. We can see here I'm generating some kind of traffic on my blog post, and we'll see that the latency at the supergraph level, so from client to router, is like pretty stable if we look at the scale here, but pretty high too. We also have latencies at the subgraph level, so we can see both subgraph, the post subgraph and user subgraph. And the latency we have for the subgraph users is a little bit higher than the one for the subgraph post. So if I want to optimize the latency here, I would try to improve latencies for the user subgraph, and that's what we'll do in this demo. And as a platform operator, I know the router now has a new feature called response caching, so I quickly enabled it using the configuration. So we can see here I enabled the response caching and for all subgraph, and it's linked to a Redis instance. It can be disabled for a specific subgraph, for example, and we can also have a Redis instance or Redis cluster per subgraph, so that's really powerful and granular. So now I enabled this response caching feature. I'll have new metrics here, which is these two metrics. We can see the response cache hits and the subgraph cache hits and the subgraph cache misses. Basically, as we only enabled the response cache feature at the router level, we won't cache anything. We have a requirement to effectively cache stuff on the router is to also return a cache control header from subgraph response to which includes like something like different than a no store directive. It could contain like the max age, the TTL, and also if it's a private data or not, to know if it has to be cached. But we have a lot of cache misses here, and what's interesting is like we're interested in subgraph users to know what we could potentially cache. We have a lot of cache misses on the subgraph users on type user, so we will potentially benefit from caching this type at the user's subgraph level. We also have the user type for the subgraph post, but we won't cache it now. So as a platform operator, I'm going to suggest to my subgraph team working on the subgraph users to cache the user entity on their subgraph and see if it's something they could do. So now I am a developer working on the subgraph users, and I know to display this page, I execute this query, the top post, and I fetch the author here, which is coming from the subgraph user, and the title coming from subgraph post. So I'm executing it. And we can see the latency here is around 250 milliseconds. It's pretty stable. And I'm going to introduce you to the cache debugger we implemented for response caching, which is pretty new, to know exactly what could be potentially be cached, and is it cached or not, where does it come from, and so on. So here we can see different entries for entities, the entity user in subgraph users. It's coming from subgraph, and we also have the root field stop post here for a subgraph post, and we can see it's all coming from the subgraph and not from cache. If it was coming from cache, we would have the source cache. If it would be cached, we would have a freshness state. We'll see later how it works. We can have more details here. We can see the cache control returned, the cache control header returned by the subgraph, basically, and it's not cached because it's set to no store. So that's the main reason. We can also see the data returned by the subgraph and the request we sent to the subgraph to have this data. So our goal here is to cache all these entries, the user entity, and have a freshness data. Freshness means it's in the cache and for a specific amount of time. So I'm on Apollo server for my subgraphs. So as I'm on Apollo server, it's pretty easy because it supports cache control, the cache control directive. I don't know if you're already familiar with this, but it's not a new directive, it's an existing one.
But what about other servers, Benjamin? Like this is available on Apollo server?
This directive is available on Apollo server, but under the hood, basically, when I'm doing this, it means I'm going to enable caching on the type user, on subgraph users, but under the hood, what it does is it will just set the right cache control header at the HTTP level. So if you're not compliant with the cache control directive, if you're not using Apollo server, you can still set by yourself the right cache control header, basically. Here I'm going to say I want to cache the user entity with a max age set to 15 seconds. So I'm going to save it and go back to my Explorer here. I'm going to re-execute it. We can see here we have the same data and the latency is still the same, but when re-executed it's way faster than before. It's around 100 milliseconds now. And the reason is, if we look at the cache debugger, we can see now it's coming from cache and not from subgraph as it was earlier. And we have the freshness state to know if it's still in the cache or not. I don't know if you saw, but it's updated in real time. So if I redo it again, we'll see that it's now coming from the subgraph, but it has been cached because we have a freshness state. It's fresh in the cache, but it has been fetched first from the subgraph, and now re-executing it, we'll see it's coming from cache. And now it's stale again because 15 seconds. If we look here, the cache control header returned by the subgraph has been set to 15 seconds as we configure it in our schema, and the data is still the same. So in order to improve latencies by a lot, I'm going to set a bigger TTL here, let's say for an hour. Yep. And re-executing it. So now it will be fresh for an hour, and everything will come from the cache.
But can we go back to the schema for a bit? So now you're saying I'm going to cache everything for an hour, but if you scroll down, there are still some things that could change here, right? Let's say the author's email address changes or whatever. So we can't assume that everything is going to remain fresh for an entire hour.
You're right. Basically, let's say one of your user decided to update his email address. Then if you still keep this data in the cache, you'll serve stale data. So basically you will serve the previous email. That's not a good experience. That's not what we want to do. And basically that's where we introduced in response caching the notion of cache tag. A cache tag is basically like surrogate cache key in REST API world. You can add a label on data that could be cached, and this label can be used to invalidate data. It's very granular. We'll see together how it works. So basically, on my user schema here, by the way, before doing that, something to know is in response caching, we're now providing free built-in invalidation requests, which is the first one is you can invalidate per subgraph. So I can say, oh, I want to invalidate my data per subgraph, so all the users, but I know my only one user, this one, let's say this one, only one user just updated the email. So that means if we're invalidating by subgraph, it would just get rid of all the cache entries for other users. It's not really efficient. We also have another built-in invalidation request, which is per type per subgraphs. So I can say I want to invalidate all the user type on the subgraph users. Still, for this example, it's not really useful, neither granular, because I would get rid of all this data here. And the third one, the new one, is invalidating per cache tag, as I said. We'll see how it works. But for this, I'm going to show you what it looks like to invalidate per type, for example. So here I have a curl command. I say I'm invalidating per type on the subgraph users and the type user. And we can see here, I'm going to move this. When doing this, I'm invalidating not only like all the data, all the cached entries for a user. We can see the count here is higher than what we would expect because I'm running a load test in the background to create traffic on my blog post. So when I rerun this, I'm not going to rerun. Oh yeah, I'm going to rerun this. When I rerun this, we can see that now it's now coming from the subgraph again. It has been cached, and now it's coming from cache. So it's a big hammer because we invalidated all the users just because one user updated their email. What we're going to do is to use cache tags. For this, we have a new directive that has been introduced by response caching, which is called cache tag. I can put a format of my cache tag. It's just the name, like the label. And I will say it's a dynamic one. I will set it to the user and use, key.id. Key here, it's like I'm going to interpolate this variable to say the key is all the entity keys available for user, and I'm going to use ID. So if the ID of my user is 42, it will generate user 42. And you can also set some kind of static cache tag if you want. You can say user or whatever you want. And let's say, for example, you know that this data is called, like this query is called for the accounts page. You can also set a specific cache tag for account set the account page, and then you'll be able to get rid of all the cache entries for this specific page. I'm going to recompose the supergraph.
So while you recompose the Benjamin, so this cache tag concept is very similar to what is available, when you cache with CDNs, where these are like business specific or application specific tags. So let's say if I want to like invalidate the whole homepage or the top post, so I can just use this tag, which makes sense to my application, my business, and use this without really having to know what that cache key entry is that I'm trying to refer to.
Yeah, exactly. And you can also decide to only invalidate the root fields, but not the entities fetched under the hood. So that's very granular. So now I composed my new supergraph. We'll rerun this query again, and you can see now I have a lot of some cache tags attached to the different cache entries I have. So for the example, what I wanted to do is to invalidate this specific data, this specific user. So I'm going to click here, and I'm going to open the invalidate modal here, and I will generate it as a curl command to use the curl command in my terminal. And to show you how it works, So basically, it's the same than earlier, but here it's the kind of cache tag. We can specify multiple subgraphs because we can have a cache tag, the same cache tag on different subgraphs, and we have the cache tag we want to invalidate. It put like 2 cache tags here. I only wanted one, so I'm going to redo it. Oop. And we see the value of the cache tag we want to invalidate. So I'm going to run it. It has invalidated 5 entries. And when running this, we can see that it's now only this entry is now coming from subgraph and not from the cache, but it has been created in the cache again. And if I do this again, it will only fetch the data from cache.
And of course, the invalidate here in the debugger is for you to be able to debug this behavior. What you're essentially doing is you're programmatically invalidating stuff on a mutation or whatever. Yeah. This is just for you to be able to debug what that might look like.
Yeah, basically you could have some kind of different scenarios where it doesn't work. You can directly see the cache control header that has been generated at the subgraph response to see if it's coming from this, the data you receive, and also if it's like a private data, you can see the private data related to this cache entry and so on. So very useful. The cache debugger is very useful to debug actually. So now I can see it works. I can refresh this and it's way faster than before. So I will be the platform operator again. Going back on my Grafana dashboard, and we'll see if what we did had an impact on the latencies and so on. So basically, if we look here, we can see that when I enabled caching on the subgraph user, we can see I have way better latencies overall at the client level. So it's way lower than before, still the same RPS, maybe a little bit more. And we can see at the subgraph level, the latencies are way lower too. And we can now see some cache hits and less cache misses on this subgraph users. And also the load on the subgraph users is way lower than before. So I think we made it. It works. And that's it.
Cool. Thank you. Can we switch back, please, to questions? JC, yes.
How you looking into using the authentication directive?
So which
handle queries that use authentication of headers, like JWT.
Okay.
Authorization.
Oh, so it's already author-aware, right? Like the.
Question, please?
Yes.
So Router can handle authorization right now,
Yes.
and has scopes and those controls. So can we add into the cache tags keys the JWT to be because it could be inherited by Router?
So you can add scopes to the fields and types like ODZ works already, right? And then the caching is already auth-aware. So what it can do is, so the auth-z plugin will say, okay, for this request, for this user, what do I need to go fetch? And then even when you cache, you understand that this details were for a different user with a different kind of scope. So when you have requests with different scopes, you'll create different cache entries. So you don't provide the ODZ scopes in the cache tag directive. That is an independent thing anyway, because you might just want to have ODZ independently. But the caching feature is already ODZ aware. Does that answer your question? Yeah.
Hi. So this is very similar, I think, to the auth question. Excuse me. In that you already segregate the responses by including the auth claims in the cache key behind the scenes. So my question is that extensible in terms of adding to that cache key behind the scenes? So, for example, if a resolver does something like does experimentation inside of the resolver, could you include, the experiment values that happens inside of the resolver inside of the cache key, kind of thing? So like, can you arbitrarily extend the
in the cache tag or the cache key?
Well, I don't know. I don't know how it would be implemented, but
but so what you're saying is you want to influence caching it separately based on some hints or something that is happening in the resolver. You want to be able to specify that I need to cache this as a separate entry based on whatever your...
Yeah, or maybe just like something that the resolver reads, but you can sort of like declare up front declaratively. So
can we do this with the customization of the cache keys?
I don't think it would be possible to do this, because if we think about this, like when we're fetching the data, we're computing the primary cache key. So we have to have a deterministic mechanism to know what's the primary key to try to fetch it from the cache and see if it's cached or not. So if I understood properly, you would like to change to change the value of this primary cache key regarding the data we receive from the subgraph, which could work if we want to cache the data, but once we want to fetch the data, we have no way to know how to rebuild this primary cache key, because the data is dependent of the data under the hood,
Okay. What if it was just kind of coming to you from a header and you've computed all of that up front, and so the resolver is kind of reading the header and then like at request time, at ingress time?
Then if it works like this, if it's like computable before getting the data, then you can create, it's like you can customize your primary cache key by using a Rise script, and you can like include a specific entry in your context to say, hey, add this in the hash when you're creating your primary cache key. For example, add the value of this header, for example, to create the cache key, and then it will create a new cache key every time this header changes.
Okay, cool. Yeah, thanks.
But very happy to connect with you later to sort of explore this further.
Hi, thank you. So quick question. Does this also help with availability concerns? So what I mean by that is if the subgraph that holds the data is for some reason just down at that moment, does it need the subgraph to be active for it to return the cached data? That's the first question. The other side of the question is, if, for example, you're using, say, requires directive, and the router is reaching to this subgraph for another subgraph to use it, does it also return that cache data to that other subgraph that requires it, or this is only important for the client calling the query?
So the first part, it is served from cache, so your subgraph does not need to be alive. But then there is another concept where you can set a certain header, which if you're trying to get from the subgraph, and if the subgraph is down, as a backup, you can sort of serve from the cache, where you have some tolerance of staleness. So that bit is not supported yet. What we can do is it returns from the cache itself, and these are for user requests. These are not for the requires or between subgraphs. Is that something that would be important to you?
Yeah, pretty important.
Okay.
Thanks for the presentation. So I have a couple of questions. First is around this invalidate feature. So right now, can we only invalidate the cache using the debugger, or is there a way to automate this solution, like codify it?
Yeah, no, so the debugger is only for debugging. It sort of shows you, what cache tags are getting populated for a specific operation and how you would invalidate it. Obviously, you're not expected to invalidate through the debugger. It's all programmatic, depending on what your application logic is, if there's a mutation or something else. So it's an out-of-band event, and that can sort of trigger the invalidation.
So I have
it's just an HTTP call.
Okay. I have one more question. It's around, so let's say you have the cache, and let's say the due to some incident or something, the subgraph goes down, but your cache is still written in the response, and that kind of brings a blind spot in the observability. So is there anything around to monitor that?
So what you're saying is, what kind of blind spot in the observability you're saying? You still will see the cache hit and thing, right? Because you've gotten it from the cache. So the subgraph availability here is not important for you to recognize that cache hit. But are you saying it's after it has gone stale, or? Yeah. So like I just said, if you have if the entry in the cache is stale, it's invalidated. That entry is gone. And if I want to get the response from the subgraph, the feature that would actually return that slightly stale data from cache is not there yet. But I understand the concern that if we were to do that, then is that cache hit? What does that? So when we implement that, I'll be in touch with you and try and understand your use case a little more.
Hi. So, I want to better understand entity caching. It seems like it's mapped to the query. So, for example, like there's many different versions of like a user from like different applications. So, are you querying like one or caching one entity per query with the same, ID primary key or whatever under the hood?
Yeah.
So basically, when we fetch data like entities on a subgraph, it sends a kind of batching request. So it's the same request on the subgraph, and we have variables to say I want the entity with ID 1, 2, 3, and we'll have a list of entities coming back from the subgraph. And we won't cache only one entry for this subgraph response. We'll cache every entity separately in different cache entries, which means we'll be able to reuse this data between different subgraph requests. And for example, in our example, we just invalidated one user, and the subgraph query has been constructed, like created, just to request this specific user, not all the batch of entities needed for the query. So it's one entity per cache entries. So we're splitting the subgraph response into different cache entries. Does it answer your question? No.
I think so, but what if the entity has a field that has a cache control header that is more restrictive than the entity itself? And you have different queries that may or may not use this one restricted field. So you're sending like one cache control header to the router. So like what happens?
Okay, so the question is like, what if in my list of entities I have one entity with a lower TTL than other ones? One field. Okay, one field. Basically, if you use the cache control directive in Apollo server, it will like inherit from the most restrictive TTL you have. So basically, if in the user entity you set a field with a TTL of 10 seconds, but the user type is set at 15 seconds, at the end the user type will have a TTL of 10 seconds. And if you set it in the cache control header, that's up to you to decide. But using cache control directive, that's how it works.
Also, the entities are cached with the specific selection set, right? So if you have different requests with different selection sets, that's actually different cache entries. So I think your question was, what if that field is included and not included? Those will be like different cache entries.
Yeah, I had a question. So I think you already slightly touched upon it, but are you guys also planning to support other cache directives such as still with error or still while revalidating?
Yes. So again, the whole point of this preview is please use it. Please give us feedback. What else is missing? So, stale if error and all of those things we do understand that those are also requirements. But yes, we will continue to build upon this.
Yes and no. I mean, you can. I will repeat the question. So, can we create this dynamic cache tag based on what the subgraph is returning, basically? Yes and no, because using the cache tag directive, you won't be able to use this because you can only use what's in the schema, and that's the current limitation we have. Maybe in the future we'll. Yeah, using the directive, no, but there is another mode, more advanced, to set cache tags. Using subgraph response, basically you'll be able to set different cache tags for different entities, and it will be part of the extensions in the response of your subgraph. So you'll be able to create the cache tags like you want, basically. It will be very flexible and programmatic. You'll use code to do this. Okay, so you're not limited by this.
Related to clients being able to specify if they can tolerate staleness or not, will router respect like client sent cache control headers? Like if you cannot tolerate any cache data, like if you set like a no cache header?
Yeah, you can set a cache control header at the request level for client to say I don't want cache data at all, and you have to. If you're familiar with the router configuration, you'll have to just say at the router configuration to pass the header cache control to subgraphs, and by doing this, you'll be able to say, oh, I don't want to cache to benefit from cache, to have cache data. I just want to have all the fresh data.
We'll take one more.
And if we're not able to accommodate, all questions, please find Benjamin and me anywhere in the conference, and we'll be happy to talk more about this.
Yeah, today with Apollo client in memory cache, we already get a lot of performance improvement techniques, and I'm guessing this is gonna add. This is an added layer of improvement that you can add at the router level to further improve latency issues. But I guess I have a couple questions around that. One is, how does the cache invalidation stuff on the Apollo client in memory cache side, that it kind of takes care of it intrinsically, like the Apollo client in memory cache is invalidated automatically when a certain entity changes as you're requesting data. But seems like with the router cache, you need to do it programmatically. Like the client, when I'm making a call to the server, I will need to in some way programmatically indicate to the server that I want to invalidate this entity. And I'm guessing there's no sort of automatic way to do that, for the server to be intelligent enough to understand that something needs to be invalidated at the router cache level.
Yeah,
that's right.
That's right.
Yeah. Okay, and how do the cache invalidations sort of come into play when you're also having client-side cache, like the in-memory cache, and you have router cache, and you want to, is there any concern of trying to sync the two, or that's not really a concern?
So they can go out of sync basically because the thing is that, let's say if you had only TTL base, then the TTL would be the same across the board. But again, as we saw on the client side, if you're caching the full response, probably the TTLs are really low. So, but now here, if you have a programmatic invalidation and if the TTL is not appropriate on the client side, we cannot guarantee that syncing of those two. But then again, with the debugger, maybe you can try and sync, try and get to the bottom of some of those things as to why you might be getting stale data.
Okay, one final question. The add cache tag directive, is it only available with a certain version of Apollo server?
Cache tag is... Sorry.
It's not related to Apollo server. It's not interpreted at the subgraph level. It's only interpreted at the router level. So it requires the Federation 2.12, I think. And once you are on that version, then you're good to go. You don't have to upgrade the Apollo server version. And if you're talking about the other directive, cache control, I think it's available starting at the specific version. But I think it's it's been a while since it exists.
Yeah. Thank you.
Well, thank you everyone for coming and in the engagement. And like I said, we'll be around, so feel free to come and talk to us. But otherwise, if we still want to explore this, set up a call with me, with your Apollo representative, and we'll be happy to explore the use cases. Thank you.